Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're moving to the next topic of the Unit C of Grade 11 Chemistry, which is the concentration of ions in solution. Now we are continue with this unit again, and we complete that unit as soon as possible. So the concentration of ions. So this is basically the concentration of the molar ions. Then we already done this topic with the volume thing. You know that we done this topic in the second unit where we're doing the same formula. Volume required is a volume given into coefficient required upon coefficient given. These are all things we did with the volume. Now we all this thing all did with the concentration. Everything stays the same. So the molar concentration of ions in a solution when a high solubility ionic compound deassociates or a strong acid ionize in proportional to the molar ratio of the balanced chemical equation. So in this, we consider the when the ionic compound deassociates, because we're doing the strong acids and weak acid thing from further from after that, and the thing called the that when the top as strong acid, which is the top six as in your acid table, they are ionized in proportional and with proportional to the molar ratio of the balance chemical equation. So I will tell you that how can we deal with, but the formula stays the same, that the coefficient required is equal to coefficient given multiplied by the coefficient required upon coefficient given. This is a concentration. So this formula stays the same, and how can we deal with those? So we discuss over there. So first question says the calcium chloride deassociates in water to produce individual calcium ions and the chloride ions. If the concentration of calcium chloride is 5.00 in molar per liter, calculate the molar concentration of the calcium ions and the chloride ions in a solution. Basically, this question is simple. They given you that the calcium chloride is converted into the this and this in presence of water. So CaCl2, which is calcium chloride in aqueous, in the presence of water we will get Ca2 plus aqueous plus 2Cl minus aqueous. This is the association reaction. We already did this. We have a concentration for the CaCl2, which is the calcium chloride, 5.00 moles per liter. We have to find the concentration for this and this. So for the concentration for the Ca2 plus, which is calcium ions, we know which is given, which is 5.00 moles per liter. You have to know this is like a balanced thing. There's a 2, so yeah, this is balanced. So we want the coefficient required upon coefficient given. So coefficient required, we did the Ca first. So it's 1 mole multiplied by 1 mole divided by the 1 mole, which is coefficient given is again over there is 1. So when you solve this, you will get a same thing, 5.00 moles per liter. For concentration for Cl negative aqueous, so we want again 5.00 moles per liter, again coefficient given upon required, which is 2 upon 1 mole. You will get a 10.0 mole per liters. So this is your for the Cl negative. So that's two things you have to find, and we find that. Everything stays the same, but just we did with the concentration now, which is easier there. Sometimes you get some like not a straightforward questions, you get some tricky questions to solve with the mass and all thing. So this question is kind of that. So the question says the solution is made by dissolving 1.35 mg of ammonium phosphate in enough water to make 250 ml of water. Calculate the concentration of the ammonium ions. So we have ammonium phosphate firstly, and it's making with the enough water of 250 ml, and we'll find the concentration of the ammonium ions. The ammonium ions can be formed after deassociation. So this is deassociation reaction. I write over there. So what is the ammonium phosphate? You can make this. So is NH4. Yeah, it's NH4. We have to write 3 like this because we have a PO4 solid. This is solid. So in presence of water, we get NH4 plus, which is ammonium ions, aqueous, plus PO4, 3 negative, aqueous. This should be 3. And this is the balance equation. Now, we have a something over there given. So we have a mass something which is in megagrams. The megagrams means like 10 raised to a minus 3, which is basically, you can say you have a 0.00135 grams. So this kind of mass you have. And if you want to find the molar mass, you can find the molar mass too for the ammonium phosphate, which is that. So with the molar mass, you calculate all the things, you plus this, you get 149.12 gram per mole. And you have a 250 ml, which should be in liters. To make it in liters, so it's 0.25 liters. We want the ammonium phosphate concentration. We have everything about the ammonium phosphate except the volume we want. So concentration we want. So for this, the concentration is equal to the the concentration is equal to the N upon V. You can find from here, you can find the N from here, which is the small m upon big M, and then you divide this by over there. So you can do that thing too, and you can do the unit analysis too to find the mole per liter thing. So for this thing, I will do with the unit analysis first. So mole per liter. So you have a 0.00135 gram thing. You have to cut the gram. So 1 mole is equal to the 1449.12 grams. And you want liters. So 1 upon 0.25 liters. Grams cancel. You get about 3.6 into 10 raised to power minus 5 moles per liter. You can do this, or you can do with this formula. At first, do with this formula to find the N, then put over there to find the concentration. You get the same answer. We want concentration for the ammonium ions, which is 3.62 into 10 raised to power minus 5 moles per liter. Concentration required upon given, so 3 divided by 1. You will get about 4 plus 1.09 into 10 raised to power minus 4 moles per liter. So that's the answer for this. The main thing is to find the concentration, which is in moles per liter with the unit analysis, or you can find with these two formulas. It's an easy thing. Last question we have. So we have to calculate the molar concentration of the sodium ions if 2.7 grams of sodium carbonate is dissolved in 175 ml of water. This is the same kind of question. So in this thing, we have a sodium with the sodium carbonate. So sodium carbonate, which is going to be the N2CO3 in aqueous, which is solid. In water, you will get a Na plus aqueous plus CO3 2 negative aqueous. This should be 2. Done. So sodium carbonate, the molar mass of sodium carbonate is about 105.99. You know how to find the molar mass, so you can find by your own. This should be in liters, so 0.175 liters. This is okay. So for the N, you have to do the mass upon the molar mass. You will get about 0.02547 moles. Then C0 upon V, so 0.02547 moles divided by 0.175 liters. When you do this, you get about 0.1456 moles per liter. And this is the concentration for the sodium carbonate. This. Now you find the concentration for the Na plus, which is equal to 0.1456 multiplied by 2 by 1. So you will get about 0.29 moles per liter. and this is your concentration. So that's how this all works. And easy calculations, same like a volume thing we did, and this is just a concentration. So that's all you have to do, and that's for the end of this lesson. In the next lesson, we are doing the one last topic before this axis and basis, which is the preparation for the standard solution, which is very, very important topic, and we do one formula in this too. So that's all for this lesson. Let me see if I do vibe learns but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's get it with Edu. Bye.